I am going to explain the power circuit and control circuit of a star delta starter. Why is starter used in case of any motor? When a motor starts, just like Newton's third law, when any body is conditioned to motion, then an extra force is required. Okay. Here also, when a motor starts, an extra effort is required. So a motor during its starting, it draws high current. So a starter is used to restrict this high current when a motor starts. Also, this starter is used as a protective device for the motor. It has overload protection and also it has many other protections that it provides to the motor. Now, I am going to define the power circuit and control circuit of a star delta starter. What is a star delta starter? A star delta starter is basically a starter when the motor starts in initial stage. It connects the motor winding in star, and after some times when it has already started and the current has reduced, it converts the motor winding into delta. Okay. Now here I have shown the power circuit of a star delta starter. Here we have three conductor units. This is one conductor unit, this is one conductor unit, and this is another conductor unit. This conductor unit is known as main conductor unit. This one is star conductor unit, and this one is delta conductor unit. Now, a three-phase motor, a starter is basically used for starting a three-phase motor. It is not used in single-phase for single-phase motor, but it is used for three-phase motor. Okay, but a dual starter or direct online starter can be used in both for the single-phase motor as well as three-phase motor. But the star delta starter, the star delta connection is mainly three-phase connection. So this star delta starter is basically used for starting a three-phase motor. Okay. Now the three-phase. Here I have shown a three-phase motor. It has three windings, three phases. This one is one phase, this one is another phase, and this one is another phase. Three-phase windings are shown. The winding of the first phase, red, suppose it is the red phase, this is the yellow phase, and this is the blue phase. The winding of the first phase is A1, A2, the winding of the second phase is B1, B2, and the winding of the third phase is C1, C2. Now, in case of star connection, now I have shown here the star connection. Star connection, what it is? The star connection is shown here. Here A1, A2, B1, B2 and C1, C2. Now, the A2, B2 and C2 are being connected at a particular point, short at one point. Okay, and the phases come out from A1, B1 and C1. So, three windings. For star connection, we have to short A2, B2 and C2. And in case of delta winding, this is the delta winding. Here, C2 point of this winding is connected with A1 point, A2 point is connected with B1 point, and C1 point is connected with B2 point. Then we form a delta winding. Okay, delta connection. So, to make star connection, we have to make this connection, and to make a delta connection, we have to make this connection. Okay. Just by changing the connection, we can convert it from star to delta. Okay. So initially when a motor starts, there is a high inrush of current. To restrict that current, we have to connect it in star. Okay? And after the current has been normalized, starting current has reduced, we will connect the motor in delta for less energy consumption. Okay? More current means more energy consumption. Okay. Now, this is the main contact. This is the motor. It has three winding A1, A2, B1, B2 and C1, C2. And this is the main conductor unit. This is the star conductor unit, and this is the delta conductor unit. This is an overload. Overload is provided to protect the motor in case of any fault. In case of any fault, there is a high current, and the overload will trip the circuit. Okay. This is the overload. Now, initially, when a star delta starter starts, the main conductor unit holds and the star conductor unit holds. And after some time, a timer sets the time, after which time the star conductor unit will leave and the delta conductor unit will hold. Initially, the main conductor unit and star conductor unit will hold, and after some time, as the star conductor unit leaves, the delta conductor unit and main conductor unit will be operating at that time. So this is the main power circuit. So I am showing you how I have made star connection. Now, here is A1, here is B1, here is C1, and here is A2, B2, C2. So for star connection of the motor, we have to short A2, B2, C2. So when this conductor unit holds, then the supply comes from here to here, and here it will be short. So A2, B2 and C2 will be short at this point, and A1, B1, C1 will bring the power to the circuit. Okay. So for star connection, this conductor unit hold and it will short A2, B2, C2. But after some time, when the timer stops the star conductor and energizes the delta conductor, then this connection is shown here. Now just see, for delta connection, what we have to do? We have to connect C2 with A1, A2 with B1, C2 with A1. Now C2, where is C2? C2. Now C2 is coming here, C2 is coming here, C2 is coming here, and here is A1. A1 is here, that is A1 is here. B1 is here, and C1 is here. So C2 is being connected with A1. Now I will see A2 is being connected with B1. A2, where is A2? A2. A2 is coming here, coming here, coming here. It is being connected with B1. Similarly, B2 is being connected with B2 is connected with where is B2? C1. B2 is being connected with C1. Now where I was? B2 is being connected with C1. So here is B2 is coming here, and it is being connected at C1. So the delta connection is complete. Now how this operates? Why the star connection and the star connect conductor and main conductor hold first, and how after sometimes the star connector stops and the delta connection holds? This has been defined in this control circuit. So I will now explain you the control circuit. Okay. Now this is a working model of a star delta starter. Here are three conductor units. This one is the main conductor unit, this one is the star conductor unit, and this one is the delta conductor unit. Initially the main conductor unit and star conductor unit will hold, and after sometimes this is the timer. after some times the timer will close the star contactor unit, and at that time this main contactor unit and the delta contactor unit will hold. Now every contactor unit, what does a contactor unit basically have? A contactor unit basically have a coil. When supply is provided to this contactor unit, the coil energizes and it makes the contact between the input and output of this contactor unit. When the coil holds, a plunger is pulled and the contactor units get connected. These contactor units basically have some main contacts where the power line is there, and some auxiliary contacts where the control circuits are drawn. This main contactor unit has its own auxiliary contacts. Here is the auxiliary contact, but in these contactor units they don't have its own auxiliary contact, so I have to fix a separate auxiliary unit to get its auxiliary contacts. These are the auxiliary units to get auxiliary contacts. Now each contactor unit may have number of NO contacts which remains normally open, and when the contactor unit energizes, it closes. Here in this working model, as I am explaining this working model in my classroom and I don't have any three-phase supply in my classroom, this model is basically being operated with a single phase supply. Okay, but it is enough to explain the working principle of a star delta starter, but here I am providing a single phase supply. Okay, now I was explaining that here auxiliary contacts are being provided with the star unit and delta unit. Now what happens, every contactor unit has NO contacts and NC contacts as auxiliary units. What does the NO? The NO contact normally remains open, that no current passes through the NO contact, but when the coil energizes, then the NO contact holds and current starts flowing. And in case of NC contact, the NC contact normally remains closed, and when the coil energizes, main coil energizes, the NC contact leaves and doesn't allow any current to flow through it. Now I will explain it later. Let's go to our board. This is the control circuit of a star delta starter. From any two phase we are drawing supply to this control circuit. From taking any two phase, or we may take one phase and one neutral, and we can supply power. No, there is no neutral in this motor. If taking any two phase, or by using a transformer, here we can step down the voltage here, and then use as here we may use also a transformer to step down its voltage in the control circuit, and then I am using this control circuit. Okay. As per the voltage of the contactor units, I have to provide the voltage in the, if the contactor units are 220 volt contactor unit, then we can provide 220 volt supply. So we will require a transformer to step down the voltage to the desired voltage of the control circuit. Okay. Now, first, when this is a overload. This overload will trip the circuit when there is any fault. Okay. Now, this is a stop switch which is normally remain closed, and when I push the stop switch, it will disconnect the circuit. Then comes the start switch. The start switch is normally open. Now when I press the start switch, then current will flow through the start switch, and here is a main contactor unit, NO contact. Okay, later I will discuss. Now when I press the start switch, now current will flow directly to the timer and to the main contactor coil. Okay, when I press the start switch, current will flow to the timer and the main contactor coil. When the current is flowing through the main contactor coil, then the main contactor unit's NO contact will be converted into NC. Then when power will come via this contactor unit. Okay. Then when I leave this start switch, then the current will not be disconnected. The current will then flow through this path as the main contactor unit has already hold. Now, along with main contactor unit, current is flowing through the timer and it is also flowing through this circuit because the timer is normally closed now. Normally closed. When the terminated timer will be actuated after a particular time, which it has been set, then the timer will actuate and it will open. But till the timer has not been actuated, the current will flow through this path. It will remain open, remain closed till the timer set time is reached. It will remain closed, and the delta contactor unit, as it is open here, current is not flowing through this. So the delta contactor unit is not charged now. So its NC contact is still closed. So this circuit is complete and current is flowing through this star coil. Okay. So the main contactor unit and the star contactor unit is now actuated. Okay. The timer has not yet reached the desired time, so this is closed, and the delta coil is open here. So current is not flowing through this circuit, so the delta coil is also closed. So this circuit is completely closed and current is flowing through this circuit, and so the star coil and the main coil, contactor unit coil, is initially holding now. Now after the timer, after a certain period of time, as I have set the timer, when the timer actuates, then what will happen? Then the timer actuates, this NC contact will be converted into NO contact, and so current will not flow through this circuit, and so the star coil will leave now. And after the timer has actuated, this circuit, this timer will close and current will flow through this circuit. Now, as the star coil has left now, as discharged now, has been stopped now, so this coil has again become NC. Initially it was NO. When the star coil was charged, it was converted into NO. Now as the star coil has left, as no power is going to is not being activated, so now the star coil's contactor unit will close. Okay, so now the timer is also closed and the star is also closed. So current will flow through this circuit, delta, and thus the delta coil will actuate. Now this main circuit is holding and the delta coil is holding now, and the star coil has stopped because the timer, after reaching some time, it has opened this circuit. This NC contact has become NO. As the delta contact holds, the delta contactor unit's NC contact is also open. So the whole circuit is open. So no power is going to the star coil. Power is only going to the delta coil. So now the delta coil and the main contactor unit will be holding, and it will continue till we stop the circuit by pressing this stop switch. This is the stop switch and this is the start switch. When we press the start switch, the current flows to this circuit, and when we press the stop switch, the current will stop flowing in the entire circuit and the total power circuit will close. The power circuit is being controlled by this control circuit. Okay, have you understood the control circuit? Now I will explain all this matter in this working model. Okay. এবার সাপ্লাই দিই দিদি এটা দেখেছিস আগে কন্ট্রোল সার্কিটটা বোঝা গেল এরকম বিভিন্ন কন্ট্রোল সার্কিট ধরে ডিজাইন করতে পারিস বিভিন্ন রিকোয়ারমেন্ট অনুযায়ী অক্সিলারি কন্ট্যাক্ট ইউজ করে। This is the start switch and this is the stop switch. Okay. This is the timer. This is the star contactor unit. This is the delta contactor unit. This is the main contactor unit, and this is the MCB to control the current in this circuit. Okay. Now let's provide power to this circuit. Okay. So as already explained, this is a working model of a star delta starter, but instead of providing three-phase supply, as we don't have three-phase supply in this classroom, so I am providing a single-phase supply to this circuit. But the main functioning will be explained by this circuit. Now, this is the MCB to control the current as a protective device. This is the timer. This is the main contactor unit. This is the star contactor unit, and this is the delta contactor unit. Initially, when this is the start switch and this is the stop switch. When I provide power, when we press the start switch, then this main contactor unit and the start contactor unit will hold, and after some time the timer will stop the star contactor unit, and then the delta contactor unit and the main contactor unit will hold till I disconnect the circuit by pressing the stop switch. Now the MCB is off. Okay, I am providing supply to this circuit. Okay, now I am switching on the MCB. The MCB is on now. Okay, now when I press you just observe, when I press the start switch, this unit and this unit, that is the main contactor unit and the star contactor unit will hold, and after some time that has been set in this timer, by this timer, it will stop this star conductor unit and make the delta conductor unit hold. Then at that time the main conductor unit and delta conductor unit will be holding, and it will be continue to hold till the supply is stopped by this stop switch. Okay, now I am pressing the start switch. The main conductor unit and the star conductor unit actuated. Now we have seen the star conductor units have stopped and the delta conductor unit has hold. Now the main conductor unit and delta conductor unit is holding now, and power is being supplied to the motor through these two units, and the motor is connected in delta connection. Now when I will stop this motor, if I want to stop this motor, I have to press the stop switch, which will disconnect the supply to this circuit. Okay, I am pressing the stop switch. Thus both conductor units have stopped, has released, and no power is being provided to the motor. This is the basic idea about a star delta starter. Hope you have understood it. Now just show the circuit diagram in this, from this side, please show it. Okay, circuit diagram has been shown. So now I am switching off the MCB and I am switching off the power to this circuit. Okay, thank you all of you.